Okay, this question 19. Find out the dispersion relation of transverse optical modes, and discuss the transparency of metal in the UV region. The UV region. Also, find out the wave vector dependence of the dispersion relation for longitudinal oscillation in Fermi gas. Longitudinal oscillation in Fermi gas. Find out the wave vector dependence for dispersion relation. So, on K, wave vector dependence. So, the first part is this transverse optical modes in plasma, but for that, we have to go a little back. Here, plasma optics, the long wavelength dielectric response, or the E omega or 0, the long wavelength dielectric response, long wavelength dielectric response of an electron gas is obtained from the equation of motion of free electron in electric field. A free electron in electric field. Free electron. So force is equal to minus E. फोर्स की जगह में लिख रहा है md2x by dt square. If x and E have time dependence, E minus I omega t, then we get this equation. So x बच जाता है क्या आ रहा है माइनस ओमेगा स्क्वायर बाहर आ रहा है और इधर माइनस साइन पहले से है तो therefore x is equal to this E by m omega square. The dipole moment of one electron is minus Ex is equal to minus E into this. तो यह minus E square E by m omega square. And the polarization is defined as the dipole moment per unit volume is equal. So NEX, where N is the electron concentration. ठीक है वॉल्यूम की वजह से. So this into volume किया concentration. So electron concentration. So this is dipole moment. So this was for one electron. ठीक है. This was for one electron. The dielectric function of at omega, frequency omega is this. So it will always be true. Epsilon is equal to d by, epsilon is equal to d by E सारा ओमेगा वाला. ठीक है. और d is equal to E plus some constant P. ठीक है. E plus P. So it will be P will multiply by 4 pi for CGS and will be multiplied by 1 by epsilon naught for SI. So we move ahead. The dielectric function of free electron gas follows from 6 and 7. This must be 6 and 7. Yes. So follows from that epsilon is equal to minus Ne square by m omega into some constant. Ne square कहाँ से आया? Ne square यहाँ से आ रहा होगा. ठीक है. Into that was by E. So it is by E. यहाँ पे एक E, यहाँ पे एक E cancel out हो जाता है. So Here we have the equations is equal to epsilon is equal to 1 minus n e square by m omega square into some constant. यहाँ पे 4 pi, यहाँ पे है epsilon naught 1 by epsilon naught. Plasma frequency omega p is defined in the relation, this one. So omega p is equal to 4 pi. Say it's this n e square by m into some constant. N e square by m into some constant. So it's here. Again, n e square. So you will have omega left over here. See, it's here. Okay. So omega 1 minus omega square by a. So a plasma in is a medium with equal concentration of positive and negative charges, of which at least one charge type is mobile. In a solid, the negative charges of conduction electrons are balanced by equal concentration of positive charges of ion core. Dielectric function तब ये बन गया plotted in figure 1. So this is figure 1. Take a nice look. Figure 1. So this is omega यहाँ पे है और यहाँ omega by omega p है. क्या लिखा है डायरेक्ट्रिक फंक्शन this or this both the same of a free electron gas versus frequency in units of plasma frequency. ठीक है, इसको कैसे डिफाइन किया है frequency in the units of plasma frequency. Electromagnetic waves propagate without damping only when epsilon is positive and real reflected when medium this is negative. So when this is negative, this region पता नहीं यहाँ attenuation क्या बोला but okay, let's move on. If the positive ion core background has a dielectric constant labeled epsilon this. Okay, we have this formula. It says if the positive ion core background has dielectric labeled this, looks like this might be ER for the background relative thing. Not sure, but moving on, you have to somehow remember this, where this is this defined as this n e square by epsilon m. Otherwise, it's just n e square by m and the constant. And the constant, it says epsilon naught, but that's the constant. n square by m. Here we have epsilon naught because ये बार वाला part में. Notice this epsilon is equal to 0. मतलब इससे पहले नेगेटिव इसके बाद पॉजिटिव when omega is equal to omega bar p. Good luck, everyone's vice. Dun, 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 dun. So we are on a side note dispersion relation for electromagnetic waves. Double time derivative is equal to spatial derivative, double time derivative of d spatial derivative e times c square or times 1 by mu. E is something like exponential of omega t plus kx वाला plus kx वाला terms. D is equal to epsilon e. I know that. So epsilon को यहाँ पे function रखा omega और k का. Then so we get this epsilon omega square time derivative से आ रहा होगा और c square k square इधर से इससे से आ रहा होगा. Similarly here what we have this क्या बोलते हैं इसको epsilon naught mu naught भी आ गया epsilon naught भी आ गया पता नहीं कहाँ से but okay. This relation tells the great deal. Consider epsilon real greater than 0 for omega real, k is real and transverse electromagnetic wave propagates with phase velocity this. See why this. For less than 0, omega is real, k is imaginary, and the wave is damped with characteristic length of this. When this is complex for omega is complex, epsilon complex, omega real, k is complex, the waves are damped in space. If epsilon is infinity, this means that the system has finite response in the absence of an applied force. Define the frequencies of the free oscillations of the medium. This is 0. We shall see longitudinally polarized waves as possible only at 0 e. Longitudinal, ठीक है. So where are we? We are here. Transverse modes के लिए यहीं पे आ जाएगा longitudinal one epsilon. This is 0. Okay, transverse optical modes. This is our equation is equal to c square k square. यहाँ पे किया उसको, पहले नहीं था. ठीक है, दिस इक्वेशन वी हैड, इसको सी स्क्वायर के स्क्वायर किया, ओमेगा यहाँ पे लेके आया है आर एच एस से. ठीक है, फॉर ओमेगा लेस देन ओमेगा पी बार वी हैव के स्क्वायर लेस देन 0. ठीक है, these go hand in hand, so k is imaginary. I. The solution of wave equations are of the form of this kx, so minus kx in the frequency region of 0 to omega p bar. Waves incident on the medium in this frequency range do not propagate but will be totally reflected. टोटली रिफ्लेक्टेड होगा इस रीजन में. दिस इज इक्वेशन बनने वाला, अभी बनानी है. वेट अ सेकंड. So electron gas is transparent when omega is greater than omega p bar. Okay. For here the dielectric function is positive real. The dispersion relation may be written as this, which comes from here and describes transverse electromagnetic waves, EM waves. Okay, electromagnetic waves. The values of plasma frequency and free the values of plasma frequency omega and free space wavelength, this is equal to 2 pi c by omega y p omega p, sorry, omega p. For electrons concentration interest, we give a given value. A wave will propagate if the free space wavelength is less than lambda, otherwise the wave is reflected. This thing तभी से बोल रहा है reflected हो जाएगा. So this दो conditions यहाँ दे रहा है, कब reflect होगा कब नहीं होगा. Of transparency metals in the ultraviolet region. For the preceding discussion, the dielectric medium, we conclude that simple metals should reflect light in the visible region and be transparent to light at high frequencies. In comparison of calculated observation of wavelengths is given in table 1. The reflection of light from metal is entirely similar to the reflection of radio waves from ionosphere. So we have a parallel. रेडियो वेव्स आयोनोस्फीयर, वैसे ही यूवी रीजन में तुम्हारा ये मेटल. फॉर फ्री, check this what I said, for free electrons in the ionosphere make the dielectric constant negative at low frequencies. ये रीजन हो जा रहा है. Experimentally results of NSB with n equal to 4 into 10 to the power 8 centimeter cube The plasma frequency is near 0.09 eV. Okay, and the second part, find out the wave vector dependence of the dispersion relation for the longitudinal oscillation in the Fermi gas. Fermi gas. So this figure 2 है तुम्हारा यहाँ पे इसके लिए ट्रांसवर्स मोड्स ऑफ प्लाज्मा के लिए यहाँ दिया हुआ है. This one was a read. Now we move to longitudinal oscillation. The zero of dielectric function determine the frequencies of the longitudinal modes of oscillation. That is this condition, epsilon omega L is equal to 0, determines the longitudinal frequency omega L near k equal to 0. Remember this, but remember omega k, omega L is not really required in these discussions. Maybe because mathematically, by the geometry of longitudinal polarization, we have there is a depolarization of field. E is equal to minus 4 pi d p discussed below. Thus d is equal to E plus 4 pi p, or for longitudinal wave in plasma more generally the crystal SIU T is equal to epsilon naught E plus p. ठीक है, दो इक्वेशंस यहाँ पे, ये बहुत अलग दिख रहा है, इसको नोट कर लो. इक्वल टू 0 for electron gas at this dielectric function 10 becomes this, because omega L, ठीक है, 1 minus this thing ओमेगा स्क्वायर पी स्क्वायर बाय ओमेगा एल, क्योंकि ये फ्रीक्वेंसी था. ठीक है, इसलिए यहाँ पे ओमेगा एल स्क्वायर को डाल दिया. यहाँ पे ओमेगा स्क्वायर था सिर्फ. ठीक है, नीचे में ओमेगा एल इज इक्वल टू ओमेगा पी. thus there is free longitudinal oscillation यही इक्वेशन का रीजन है, इसलिए यहाँ पे कट ऑफ बनता है. ठीक है, ये जो रीड दिस लाइन, thus there is a free longitudinal oscillation mode in figure 4 of electron gas at plasma frequency described in 15 as low frequency cutoff of transverse electromagnetic waves. See this. A longitudinal plasma oscillation with k equal to 0, ये सब k equal to 0 पे चलो. तो पहले shows in figure 5 a uniform displacement of electron gas in a thin metallic slab. The electron gas is moved as a whole with respect to the positive ion core background. The displacement U of the electron gas creates the electric field E 4 pi E and U. ठीक है, तो this is also creating an electric field that acts as a restoring force on the gas. The equation of motion of this NEE 4 pi, this 4 pi NE n square E square U. So n okay, I don't know how this can stay put. These are more equations. D's double derivative with respect to time of U plus omega p into u is equal to 0, so omega p is equal to this. This is equation of motion of a simple harmonic oscillator with omega p frequency of the plasma. The expression omega p is identical to previous omega p value, which arose in a different connection. The SI displacement U creates the electric field E is equal to this NEU by epsilon naught. Omega p is equal to NE square epsilon by epsilon naught m. The wave vector dependence longitudinal oscillation become given by this 3 square square ऊपर में by 10 is नीचे में square omega p के ऊपर, where Vf is the electron velocity. La la. Take a look. Whatever this is.